Now, let's let it drop through. It approached from above, right? It came down from above, and there was a repulsive force from the induced current in the loop wire to the falling magnet. Now let's let it fall through. So it's dropping down below like this. What happens now? In our loop of wire, what's happening? What direction is magnetic flux from the magnet? The magnetic flux is down. As the magnet moves away, drops away from the loop, what's happening to it? It's decreasing. So what direction is the current here? It has to have a magnetic flux down to add to the flux that's decreasing. It doesn't like it decreasing. It wants to add back to it. So it adds to the decreasing flux, try to get it back to where it was. So we could replace that loop of wire with a magnet. North side down, right? Its flux is pointed down. What kind of force do we get here? An attractive force. That should make sense because it always has to repel the motion of the magnet. Otherwise, if it didn't repel the motion of the magnet, we could get free energy out, right? We just start it moving, and then the force causes it to keep moving, and we get more energy out, and the force causes it to keep moving. The force always repels the motion. Let's take a look at this. I've got I don't have a single loop of wire. It's hard to see if you just have a small loop of wire, but I can make a whole bunch of loops of wire together. How do I do that? I get a conductive pipe. So this aluminum pipe, it conducts, so it's like a whole bunch of loops of wire all wound together, right? It's a conductive pipe. It's aluminum, so magnets do not stick to it. One of these is a magnet. This is not a magnet. So I want to drop this through so you can see about how long it takes to get to the other side. Can you see the bottom of that, Steve? So I'll drop it. Comes right out the bottom, right? Very quick. Now I'll drop a magnet through. As the magnet drops down and it approaches a piece of the conductor, currents get set up that repel it. As it drops past some of the conductors up here, it induces current in the opposite direction, which attracts it. So it always hinders the motion of the magnet, always slows it down. You ready? Let's drop it in there. Okay, comes out there. If you have a really strong magnet like this, and you drop it in there, you can go get a cup of coffee. There it is. Takes a long time. It's really fun to watch it go down. It just floats nice and slowly down. After class, you can do that. Okay?